Right, so in this video I'm going to have a look at Leaving Cert Higher Level Maths Paper 1 2017, and I'm just going to have a look at question 6. So this is it here. We're given a graph of function e to the power of x. It's drawn here. I'll show you that in a minute. And it's drawn between 0 and 1. On the same diagram, draw the graph of h of x, which is e to the power of minus x, in the domain x is greater than or equal to 0, less than or equal to 1. So we've got to draw e to the power of minus x. Okay, so this is our graph here, and we have another function here, h of x, and that's e to the power of minus x. Now, in order to do this, you can just plot a few points here. I mean, we have on our x-axis here, we've got 0, 0.2, 0.4, 0.6, 0.8, and 1. So let's use these as our points, and we're just going to, you can just stick them into your calculator, into your function part of your calculator, and it will give you your y values, or you can just simply calculate them individually. So I just key them into my calculator, and I got these are my x values here, these are my y values. So I put in 0, 0 0.2, 0 0.4, 0 0.6, 0 0.8, and 1. And the y values that I got out, now I just did them to 2 decimal places. So if you put in 0, e to the power of 0 is just going to be 1. E to the power of minus, so we're doing, this is just going to be e to the power of minus 0.2. And when you do that, I got 0.82 to 2 decimal places anyway. E to the power of minus 0.4 was the next one, and that was 0.67, 0.67. And then 0.6, so all I'm going to do is e to the power of minus 0.6. You can just do that on your calculator individually if you want. So I got 0.55, and then this one here, e to the power of minus 0.8, that was 0.45, and then e to the power of minus 1 is 0.37. So if you plot those points, let's have a go at doing that. Let's see. I'll do it in this color here. Okay. So let's see. We've got point 2 is has a y value of 0.82. So that's going to be 0.2 here, and then we got to go up to 0.82. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be roughly here somewhere. Next one, 0.4 is going to be 0.67. So we're going to go 1, 2, 1, 2, 3, 4, 5, 6. So it's going to be around here somewhere. 0.6 is 0.55. So it's 1, 1, 2, 3, 4, 5. 0.55 is going to be here. 0.8 is 0.45. So it's 1, 2, 3, 4. And halfway up, which is here, and 1 is 0.37. 1, 2, 3, 7 is going to be somewhere around here. So this is our graph here. So you just draw, you can connect these up. Oops, okay, a little bit shaky, but you can do it a lot smoother than that one there. So that's it really. And I should have that drawn here a little bit more accurately. This is drawn on GeoGebra, so you can see what it looks like. This is our e to the power of x here. This is our e to the power of minus x here. So it's a little bit better here. Okay, so that's the first part of the question. Next part then involves some integration, I think. So let's have a read of it. Find the area enclosed by e to the power of x, e to the power of minus x, and the line x is equal to 0.75. Give your answer to 4 decimal places. Well, x is equal to 0.75 is going to be a vertical line, and it should look something like this. 0.75 will be, well, there's 0.8, there's 0.6, 7, so 0.75 will be there. So it'll be a line going up along here like this. So there's our line, x is equal to 0.75. So we got to find this area in here, the area enclosed by this kind of, it's not exactly a triangle, but this area in here. So the way we're going to do this is we're going to integrate this function here. Now remember this x value here is 0.75, this x value here is 0.75, this x value here is 0. So we're going to integrate this curve here, which is e to the power of x, between 0 and 0.75. That will give us this area down here, all of this area between the curve and the x-axis. Then I'm going to integrate this curve here, this red curve here, which is e to the power of minus x, again between 0 and 0.75. That will give me this area down here, between the red curve and the x-axis, and the y-axis indeed. I'm going to subtract those two areas, and that will give me the area in here. So that's what we're going to do. So let's start that. Okay, so let's write it out what exactly we're going to do first. So we're going to find the area enclosed, and that's going to be the integral of e to the power of x between 0 and 0.75, and then we're going to subtract the integral between 0 and 0.75 as well of e to the power of minus x. So this should give us the area that we're looking for. So let's work this out. Well, the integral of e to the power of x is just e to the power of x. And we want to put in our limits here, which are 0 and 0.75. Now, the integral of e to the power of minus x is minus e to the power of minus x. I'll just go through that in a second. But again, we're integrating that between 0 and 0.75. Let's just have a look at where that came from. If we take e to the power of minus x and we want to integrate it, well, there is a rule, it's in your tables. It just simply says that e to the power of ax integrated, the integral of e to the power of ax is 1 over a e to the power of ax. Okay, so if we take this here, if we take e to the power of minus x, e to the power of minus x, well, really that's minus 1x here. There's a 1 there, okay? So it's our a here, if you like, is minus 1. So if we integrate this, then we'll get 1 over the a, so it's 1 over our minus 1, e to the power of ax. Well, our a is minus 1, so it's just minus 1x, or minus x. So that's just simply, this becomes minus 1, and this is e to the power of minus x here. So that's where I got this here from. Okay, so let's just calculate all of this then. Okay, so we want to put in the 0.75 first here, so I'll put this in brackets here. So it's e to the power of 0.75 minus e to the power of 0. Now don't make the mistake here of seeing this 0 and just putting in 0 here. Remember, e to the power of 0 is 1, so this is actually 1 here. So we are subtracting 1, not subtracting 0. Okay, so next then we're going to do this bit here. So we've got to put in the 0.75 first, so it's minus e to the power of minus 0.75, and then we've got to subtract minus e to the power of minus 0. Okay, so this is what we've got to work out. Let's just take away the brackets here and work out these one or two little bits here anyway. I'll leave this as it is, e to the power of 0.75. e to the power of 0 here is 1. Here we've got a minus minus, so that's going to be plus e to the power of minus 0.75. Now these two minuses here will be plus. However, this minus here will make that minus. Minus times plus is minus. And now you've got e to the power of minus 0, which is just e to the power of 0, which is also 1. Okay. Now, when you actually work this out, you can just do this on your calculator. It's fairly straightforward, but you'll get 0.5893665,694. The question actually says, I think it says, give your answer correct to 4 decimal places. So let's do that. Well, here's 1, 2, 3. There's 4 decimal places there. So this is a 3. There's a 6 after it. So we're going to round this up to 4. So this is going to be approximately equal to then 0.5894. This is our area between those 3 curves. Okay, so that's it for this video.